Hi there, in this lesson we're looking at National 5 Applications Specimen 1, questions 11 and 12, basically the statistics questions. Okay, let's look at question 11. So a machine is used to put drawing pins into boxes, a sample of 8 boxes is taken and the number of drawing pins in each is counted. The results are shown below: 102 pins, 102, 101, 98, 90, so on. Let's calculate the mean and standard deviation. Yeah, that's our first task. So the mean is basically when you add them all up and divide by how many there are. The maths notation for this is x bar. You'll see that in the standard deviation formula in the formula sheet like this. So add them all up, you'll get 808, you've got a calculator, and divide by how many there are, which is 8, so 101. Now, to get the standard deviation and work with the formula, you need to get this first top line, okay? So to get that top line, again, I'm not going to go into too much detail here. If you want more detail on the standard deviation, watch the video lesson on that. But to get this top line, basically what you're trying to do is get the difference between the mean and these numbers. And you draw a table to do that. So we're trying to basically write all these numbers out from up here, 102, 102, 101, and so on, in a big list. And you subtract the mean from each value. So the mean's 101, so we're doing 102, take away 101, which is 1. Same again. 101 take away 101, 98 take away 101, minus 3, 99 take away 101, and so on. Now, next what you have to do is you have to square each value. The reason for that is if you add all these up here and divide by how many there are, when you add all this up you get 0, and it doesn't work. So basically you have to do a wee math trick, square it and square root it again. So let's square it. So we've got 1 times 1 is 1, 0 squared is 0. Just be careful here, negative 3 times negative 3 is positive 9, negative squared is positive 4, 0 squared 0, 2 times 2 is 4, and 1 times 1 is 1. Now add all that up and you get 20. Now that is the top line of your formula. This is the tables there to get that top line of your formula. So we'll fire that in. So to get the standard deviation, we're doing the square root of 20 divided by how many numbers there are, take away 1. So there's 8 numbers here, you can see 1, 2, 3, 4, 5, 6, 7, 8. Take away 1 from that, you get 7. Do that calculation first. 20 divided by 7 will give you this. Just leave it in your calculator, hit the square root button to finally get 1.69, and that's your standard deviation. Right, let's look at part B. A sample of 8 boxes is taken from another machine. This sample has a mean of 103 and a standard deviation of 2.1. Now I'm going to call this sample 2. So you're trying to make 2 comparisons between the samples. Now the comparisons are basically, you're looking at these things because the mean, you're going to compare them, and you're also going to compare the standard deviations. They're the 2 kind of things they're looking for you to do. So this is the second sample. So you can see in the second sample the means got higher, and that's what I'm going to write first for 1 mark. Sample 2 has a higher average number of drawing pins, and you could say than sample 1. Sample 2's standard deviation is higher as well. So sample 2 has a higher standard deviation, but the mark you will not get at that point. You need to explain what's going on. What does a higher standard deviation mean? Now a higher standard deviation means the data is more spread out. The difference between the largest and the smallest will be bigger than something with a smaller standard deviation. Okay, so let's write that. Sample 2 has a higher standard deviation, which means the number of drawing pins per box is more spread out. Another way to say that is less consistent. It's not as consistent, it's more all over the place. Now, if you don't write that down, you just say one's got a higher or smaller standard deviation, you won't get the full marks. Those are the 2 things we're looking for. Okay, question 12. So students in S3 sat exams in physics and maths. The results from the exams were plotted in a scatter diagram. And a line of best fit was drawn, wasn't it? So there's your line of best fit. So determine the gradient of the line of best fit, and you've got 2 coordinates on there. So that's just a y2 take y1 and x2 take x1, or delta y over delta x question, using these coordinates. So remember, the y values are the second numbers, and the x values are the first numbers. So you want to subtract the y's and put it in the top. I'll do 30 take away 20, and then 30 take away 10 in the bottom. Now that's 10 over 20, which will simplify to a half. Okay, question part B. Find the equation of the line in terms of m and p. I guess because m is maths and p is physics. Now I'm going to do it with x's and y's first. And because you've got no intercept here, and you've only got 2 coordinates, the technique to do this is use y take b equals mx take a. Now, to get my gradient, I just use this bit here, so that there will feed into here. And also, you can use either of these 2 coordinates for your a, b. Now, I'm going to use that as my a, and that as my b. Again, you could have used the 30 and the 30, but I'm picking the smaller values. So let's fill it in. So we've got y take b, which is 20, equals a half. Then we've got x take 10. Now, I don't really like the fraction here. I'm going to try and get rid of that. In order to do that, I need to multiply by 2. Only the multiplier here, not the bracket as well. And that would end up timesing. If you times that by 2, that by 2, and that by 2, that'd be like timesing by 8. I'm going to times that by 2 though as well, and that by 2. And that will be my next line. So I've got 2y take 40, and that's just 1 times x minus 10, so I'm just writing it as x minus 10. The next thing I'm going to do is I'm going to try and get it down to y equals, so I'm going to add the 40 to both sides. That will cancel that one out, and add the 40 to the other side. That leaves me with the 2y, and then negative 10 plus 40 is 30. And because I want it down to 1y equals, I'm going to have to divide everything by 2. So that means divide that by 2, and divide this by 2. So that'll get me 1y. You could put a half x. I'm going to write 0.5x because I'm using a calculator, and then that will be 15. Now just to finish here, it says give the equation of the line of best fit in terms of m and p. So let's look up here. P is physics, and that's the y-axis. So I'm going to change the y to a p, and the maths is the x-axis. So I'm going to change that to an m. Right, the final question says estimate, I'll get rid of that there, estimate the physics mark when the maths mark is 22. So I'm going to use this formula that I just got here. And we're basically saying that the maths mark is 22, so I'm going to put the 22 right in there to work out the physics mark. It's kind of a formula to work out physics, isn't it? If you know the maths mark. So 0.5 times 22, and then you add on the 15. So you're just halving 22, basically. Adding on the 15, 26 to finish.